Let's start off today by finding the volume of a regular pyramid. Remember that volume means how much space is taken up on the inside of any shape. In particular, how many 1 by 1 by 1 cubes can fit inside any three-dimensional shape. Here's the formula. Volume equals 1/3 area of the base times the height. The one thing you do need to remember is the height is the length from the tip of the pyramid straight down to the base of the pyramid, making sure that they form a 90-degree angle. Let's start off by doing a pretty simple example. Here is a square pyramid. The base sides are 13 units and the height is 15 units. Let's start off with the formula. Volume equals 1/3 area of the base times the height. We're going to go ahead and find the area of the base, which is a square. To find the area of a square, it's just length times width. 13 times 13, that gives you 169. And then just multiply that by the height. Using your calculator, we should get the final answer to be 845 units cubed. Again, a reminder that whenever you're dealing with volume, the units are always cubed. Here's another example of a square pyramid, but this one is slightly more difficult. Notice that the base is still a square with base side 16 inches, but this time we have a fancy L. Remember, the fancy L stands for the slant height, and that is 25 inches. Let's go ahead and plug into our volume formula. First, we have to find the area of the base, which in this case is 16 by 16, which gives us 256. Now we have to plug in the height. Here's the height. To help solve for the height, it would be helpful if we drew in a right triangle like that. Notice that the base of that triangle is 8 inches. It's half of the 16 that you see there. Go ahead and use the Pythagorean theorem to solve for the height. I'll give you a few seconds. Alright, the Pythagorean theorem should produce the height for you. And the height turns out to be 23.6854. Now that we have all the information, go ahead and plug that all into your calculator to get the final volume of this pyramid. 2021.1474 inches cubed. Let's go backwards for a little bit. This problem asks you to find the height of a regular triangular pyramid with base leg 12 feet and it has a volume of 500 centimeters cube. It is always a good idea to draw a picture of what they are asking for. Here is a regular triangular pyramid. Notice the base of the pyramid is a triangle, and the base legs have 12 feet all the way around. Let's go ahead and write the volume equation. Volume equals 1/3 area of the base times the height. Now we have to find the area of the base. Oh, before that, we can go ahead and plug in the volume that we already know, which is 500. Now let's find the area of the base. There is the base. It is 12 feet all the way around. Remember, that's what regular means. Regular means that all the sides and all the angles are the same. Let's go ahead and find the area of that base. There's the height of it. Notice half of the base is 6. Using the Pythagorean theorem, you should be able to find the height of that triangle to be 10.3923. Once we have the height, we can go ahead and use 1/2 base times height to find the area of that triangle. The base of that triangle being 12 and the height being 10.3923. Putting all of that into your calculator, that base is at 62.3538. We can go ahead and plug that into our original formula. Go ahead and do 1/3 times 62.3538 to get 20.7846. And then now it's a pretty easy pre-algebra problem to solve for the height. Divide both sides by 20.7846. And the height turns out to be approximately 24.0562 feet. Let's move on to the volume of a cone. The formula for a volume of a cone is exactly the same as the volume of pyramids, 1/3 times the area of the base times the height. But if you didn't notice something particular about the base, it is a circle. And of course we know the area of a circle is pi r squared. Alright, let's go ahead and find the volume of this cone. We'll start off by writing the formula down. Volume equals 1/3 area of the base times the height. Let's go ahead and find the area of the base. Notice the base again is going to be a circle, pi r squared, the radius being 8. Go ahead and use the pi button on your calculator. Don't just do 3.14. Multiply it by 8 squared. You should get 201.0619. Now to find the height, we have to draw in a triangle. Using the Pythagorean theorem once again, we will find the height of the cone to be approximately 13.8564. Now that we have our information, go ahead and plug all of that into your calculator to get the volume of the cone to be approximately 928.6648 centimeters cubed. Let's find the volume of a trickier shape. Here we have a regular hexagonal pyramid. The formula to find the volume is the same, 1/3 area of the base times the height. Let's go ahead and look at the base. Notice it's a hexagon. To find the area of a regular hexagon, we have a different formula. Area of the hexagon is 1/2 apothem times perimeter. Remember, this is where the apothem is. In order to find the apothem, we need a little bit more information. We need to draw in a little triangle. Notice that this is the triangle that we're going to use to help find the apothem. The base of the triangle is 6. It's half of the 12 centimeters. To find the angle, the central angle up there, remember the rule was to do 360 degrees divided by however many sides there are. In this case, we have 6 sides. So 360 divided by 6 gives us 60 degrees. And that gives us the angle, the central angle. But we don't want the central angle, we actually want half of the central angle. We're dividing it by 2. So 360 divided by 6 gives you 60, and then we cut that in half to get 30 degrees. Now, at this point, we actually have 2 ways to find the apothem. If you remember your special right triangles, the apothem is 6 square root of 3. If you don't remember your rules for special right triangles, you can still use SOHCAHTOA. In this case, tangent of 30 is equal to 6 over a. Use a little bit of algebra to solve for a. Either way, the apothem is approximately 10.3923. All right. Use that to plug back into the second formula for the area of the base right here. Notice we're missing the perimeter still. The perimeter is pretty easy. It's just the distance all the way around the base. So 12 times 6 gives us 72. Plug all of that into your calculator. The area of the base is 374.1223. All of that work just to find the area of the base, so you can plug it back into the original formula. The very last thing is just plugging in the height, which is 20 centimeters. All of that into your calculator will give us our final answer for the volume, 2,494.1487 centimeters cubed. Okay, we're going to save this problem for the section for composite shapes so that we can do that later when we reach that section. So you guys are done for today. Thank you.